Hello, and welcome back to another devlog. Um, this one is number 30. So, I began working on Monday to attempting to do the first case, which is uh, the camera will fade through the walls. Uh, so I tried to repurpose my previous alpha fade solutions for the um, for what I used in when the background or the game loads in the background, the fade in and also the pause menu, like you can see when you pause the game. Um, there is I wonder why that's not working. Oh, it works in the game view. Yeah. So you see in the VR, it's actually, but it puts this overlay where it kind of, this world overlay where it kind of subtly fades in the background in VR. So I tried to employ that in the situation over here, but I found that doing the same thing in like an update loop to like lerp and set a material alpha value. Um, it was really clogging up the CPU cycles. You can see CPU, like instead of like 13 milliseconds, it would really spike to like 61, and that would kill the FPS when actually. So my original solution was to use a collider here, and when you go into this area, it would actually fade out the whole wall. But that wasn't quite working. So I kind of scrapped that solution. But I noticed my out-of-the-box dithering solution from Amplify was actually using shaders to do this kind of effect here. And it didn't have the same issue because it was manipulating the graphics directly on the GPU with a shader. So I took that Amplify shader and tried to apply that to my solution with the collider here. I didn't initially like that because it was doing more of a you can see here it was doing more of like a circular. It was detecting where the camera is located in the shader and doing it automatically. So I didn't need a actual collider to tell it to do the wall, but I kind of wanted it to do the whole wall, not just to where the camera is positioned. Eventually I got it to where it was acceptable, so I didn't have to use the collider. And this is, so it allowed, instead of like the camera like a hard clip through the wall, it kind of fades out and you can see, especially from this angle, you can actually see what's going on in the other end of the hall. Your view's not obscured. So this solution worked pretty good for this case. So I kind of went with this with Amplify. I was able to kind of replicate their out of the box material and apply this this shader to it. So it looks the same as the other walls in this work. So on Tuesday, I decided to start working on the up case, and instead of this shader, I'd have to do a different way where I'd have to directly control. So when you go into this room, I want to, fade out this top wall, not all the other walls, but this top wall, so you can actually see the player. So this solution, maybe you can actually get stuck on this door. That's interesting. That's an interesting issue that I just noticed. But anyways, it's using colliders here, and when you're going into this other room, it can kind of detect and then it'll control manually with a value to fade in, fade out. So it's not, because the camera is way over here, it's not going to work because the camera is not close to the wall. So it has to be triggered by a collider in this case. And so it can fade out a little bit further ahead. So had to kind of modify my amplify shader for this case, but I got it to work. No problem with the colliders. So the problem started to come in with my solution when I tried to apply this kind of solution to the down case. So the issue was that, go to the down case here. So previously I had this concrete wall, and I was able to replicate the look with an amplified shader to match this wall, so it didn't stick out like as a, the texture and the color didn't look different. It matched the wall with the amplify. But I could not, for the life of me, I could not get the ceiling. If we look at the ceiling tiles here, I could not get these ceiling tiles to work with my shader because it had these different like detail textures and emissions that my amplified shader didn't support. So try as I might to adapt my amplified shader to get the matching look, I was just unsuccessful, and I was just going around in circles. I was doing a lot of tinkering and mucking around, shooting the dark. But I really had no idea what I was doing or how the system worked with amplify shaders. So I really got into the weeds and just kind of tried to get it to work. So I eventually kind of scrapped that, and I dug up a shader that I used previously for my stealth shader. It was an out of the box shader that in shader graph, not amplify. So we have so we have, open this up. I have two different, so here's this one, and then I was working with this, so it's like two different systems. This shader graph is Unity's solution, and previously I was working with Amplify. Let's see here. Oh, there it goes. So it's a whole different system. It's mostly the same, but this Amplify, it actually works as a visual coding solution for HLSL. And I kind of got, with AI's help, I kind of got a little bit more hands-on with writing actual HLSL code. It's a whole different system, and I don't know how it really works. It's just too much for me. But so I eventually worked with this out-of-the-box solution, and I still didn't really know what was going on with all these nodes and how they worked and all that. I was just tinkering and kind of not really getting it to work, even with the out-of-the-box solution. So I finally sat down with like a step-by-step video tutorial on how to actually recreate a standard lit URP shader, and this is the result. So I started with nothing, and I'd follow step by step. Each of the nodes, for like the normal color, the normal texture, hooking it up step by step and really understanding and ironing out my knowledge on how this shader system works, and to where I have this base URP node that I understand and that I can actually append onto in the future, like add a add a dithering effect or add some other sort of effect on top of the standard URP. So that way, and I was testing step by step, with, building it up from scratch, to actually match the original materials look close enough, because like so this could be applied to any material out of the box, from my third-party assets. So I can actually add functionality like dithering to a dithering control, and it would match the actual standard tile without sticking out. So that took a bunch of work to finally get working. By the end, I had pretty much vastly increased my understanding of shader nodes, how to use them, uh, instead of being completely unknowledgeable about these sort of things. I'm still not an expert, but I'm not totally ignorant anymore. So Wednesday, I was able to create the URP lit and add the dithering effect on top of it. I cleaned everything up, and I got the this case working with colliders. So as you've seen before, depending on if you go in this room, the hallways fade out, and then going back in, they kind of fade back in. So that's pretty cool. So I kind of turned to working on the ceiling height adjustment issue. So if we go over here, let's see if we can go to the so in this case you can slightly see it. Let's see if I can mess around with the camera to yeah, that's more dramatic. I'll set that for that. I'm not sure why in game view it actually is so close here, but we'll just go with this for now. So before, when I was in the hallway, the ceiling height restriction, and if you entered the larger room with a higher ceiling, it would zoom out properly like this, right? But if you go from a higher to a lower, as soon as it's occluded, it would actually snap. It would just boom, snap. So I was able to get in and modify the actual camera behavior to actually, when this happens, when the actual camera is occluded by a culling layer, it won't just snap to position. It'll actually zoom down the height like it does in the opposite case. So that is working how it should. And then on Thursday, I noticed an issue with my down case that we're just talking about over here. So you start off in this state, everything's faded out, and you can go back in. Okay, that's fine. But what happens if you actually take an alternate route and you come back around from the opposite way? Well, previously, what would happen, let's just say you're coming back to the main room from this way. Previously, what it would be like, you look down this hall and it would be faded out because the on and off switches would be being controlled by box colliders at the doorway, right? So if you take an alternate route, it would be in the wrong state. So how to fix that? So a new solution would be to use sectors, and so I pretty much had to sectorize my level here. I was gonna do this anyways, because I had to test a bunch of other things. But I pretty much hooked up all these different areas with sectors and portals, so it's all connected. So now this means that I was able to implement something where, depending on which room you're in, so not relying on colliders at the door, but actually now you can see in this upper right hand corner, I did away with the camera screen overlay, and I figured out how to do an actual in-editor overlay on the scene view to actually display the information without that weird uh, artifacting of the camera having to catch up with the scene view camera. So you got your information here, and I had to go back and review my actual sector construction for this custom level because I was working with a demo, and I worked with setting up new portals and stuff in my testing, but I had to go back and review how to do that correctly. And with this custom setup, it was a little different on the way you detect changing sectors, because I had to detect only when you change a sector through a portal. And since in this setup you actually have sectors overlapping, so you can't be you can put the old default system, you can be in multiple sectors at once, but I only want to know if what sector I'm in based off the portal I entered or went through, right? So I got that working with some testing, figuring that out, and now it actually tells you which sector you're in, no problem. And so depending on that, I set up another global event message system that'll actually um, report globally what sector the player is in, and depending on that, if he enters the room sector, it'll control this sector and say, oh, fade, go to the fade out state. But if you leave this room, it will fade it back in. So it solves the problem of taking an alternate route and it being in the wrong state. So with this sector, the sector setup now, when I load additional scenes in the future, I'll have to make sure that these portals in the scene loader, these portals are connected properly, because now it depends. It depends. The player room detection depends on these portals being linked up properly from scene to scene. Um, so now I'll have to do that. So now, if I have that system in place, now I can actually say I can have these dependencies to say, oh, this is a down room and this is the up connecting room. I need to have a reference or a string reference to this, a string reference assumption to this room, so that when I do get a message, I can actually use this room's name to compare it to and say, oh yeah, he left this room, or it's not this room. I'm going to turn back on, or send a message, yes, the name is this room. I heard that. I'm going to turn that back off. So that's kind of how it's going to work um, from here on. So got all that working. On Friday, I turned to the next issue. I wanted to do this a sidewall camera dead zones. So we go to the game view here. If you look over here, and so the behavior now is that you can get right up to the wall and you can see through the wall and you can see what's going on the other side. I don't even want that, and especially in the hallways. I kind of same thing. I don't really want the user to be able to get all the way up to the wall. I kind of want a dead zone. And what I'm talking about, I actually was able to implement this where I overwrote the camera behavior. I have this. Let's go and follow. If you look here, I was able to write a script with AI's help to actually take the take a sidewall and pretty much, if you can see here, this mesh here, it'll take the mesh of the sidewall, it'll copy it, and it'll kind of offset it in a direction left and down to actually guide the camera if there is a sidewall. And this is controlled in a script. So basically, turn these back on. What happens, I had to do some messing around, and if you go to the game, you can now see there is not a dead zone for some reason. I'm not sure why that's not working, but let's try one more thing before I throw in the towel here. Okay, so that's not working properly for the demo. Let me see if I can fix this real quick and I'll show you. Okay, I got it working again. So this is what happens now. If you approach the wall, there's this sort of dead zone, so that the camera kind of stops at the wall and you can't really approach it. And then once you reach a certain point, it'll actually, I had to modify the behavior where it wouldn't snap, but it would kind of zoom or alert back to the player's X position like that. And so that's all great, but in the end, it kind of needs some fine tuning because there's some cases where, like, let's just say the player goes over here and gets close to the wall. Now you can actually get behind the collider and be close to the wall in this case. So I have to do some more work next week, kind of fine-tuning and adjusting the solution. But the dead zone behavior override for the camera is working, and that's great. So I was kind of struggling in implementing this because I was trying to use rigid bodies, but that wasn't working. But I pretty much went to using trigger collision in order to stop the camera, and that worked properly in getting this to work. So let's see. So other than that, fine-tuning this camera dead zone functionality, I kind of have to test some issues with sector camera culling in VR. It's kind of not working. It's kind of get some odd issues where just when you look around, his body disappears and his head's showing up, and other things with camera culling and sectors with this new solution. And then one of the things I found a nice little sound effects for opening and closing doors, and I kind of wanted to do implement my own solution with do a little bit of animation work to kind of animate the opening and closing of the doors. Just a basic animation and then when you approach the door and such, you know, because I kind of want to use this door asset here. So that's for next week. We're pretty much coming down to all the major cases of the camera behavior control features and functionality. So stay tuned for that, and thanks for joining us this week, and we'll see you next time. Bye.